Hello everybody. Okay, so today we're going to talk about calculus. Now, a couple things about calculus is that everyone gets very freaked out because it kind of does look scary. If you look at all of these items, and in the beginning when you see all of this, you are going to freak out and you're going to be like, "Oh my gosh, I don't know what's going on. I'm not sure what's going on." I left you off with the last lesson where we spoke about limits and how to use a limit, and we practiced doing first principle. But we're going to continue with that in this next lesson. But give yourself a little heading, give yourself calculus, and enjoy this journey because it's actually a really fun journey. Calculus is used in physics and engineering, and it basically just helps you identify how something is changing in a specific point in time. It's very simply put. Okay, so if we look at this, we're going to deal with something called differentiation. Now, differentiation, the definition for it is the process of finding a derivative. What is the derivative? Well, a derivative is something that relates to the rate of change. So the process of finding a rate of change. Now, when we look at this graph, let me just get my little spotlight going here. If we look at this graph here, I've drawn a cubic function. Okay, this is a cubic function. Half of it this side is a sad parabola, half of it this side is a happy parabola. Put together is a cubic function. We're going to do a bit more on cubic functions in the next section. But when we're looking at this graph, what you should notice is that wherever I put my highlighter at this point, it's changing. The item is changing at each point along this curve, right? If we look at this highlighted point, which is focusing on this dot right here, that means at this point in time, or as we're moving along the x-axis, what is happening according to my y value? Well, it's staying over there. And as I move up here, my x value is increasing and my y value is increasing. And then over here, we start to decrease. Our x value is increasing while our y value is decreasing. So this is the decreasing part of this function. And then over here again, we're going to start to increase again. Now, you guys have been dealing with graphs for more than 3 years now. And when we look at this, we can see that we end up drawing a straight line at this point, almost a tangent to this point. It is a straight line drawn where this point, where it touches on this graph. And we know that this like slope ends up being my gradient, right? So all differentiation does is it allows me to calculate my gradient for this graph. And I will use a formula and I'll use differentiation rules to be able to do that. And once I find out what my gradient is of this graph, that gradient represents this line, that line, that line, that line, all at different x points. Okay, so again, differentiation is just looking at how do I figure out the rate of change, and that rate of change will be defined by the gradient of this graph. And the gradient equation for this graph will be the same one throughout. And as soon as I substitute my x value in, I'll be able to get the specific gradient at each of these specific points. So it's a really cool thing. You don't have to use that equation m is equal to y2 minus y1 over x2 minus x1 anymore, because this takes over that whole problem. When we're looking to calculate the value of a derivative at a point, so at this point, how do I calculate the derivative? I'm going to use the definition of the derivative, or I'm going to use rules for differentiation. Now, rules for differentiation, it looks a little confusing over here, but it really isn't that difficult. I've just drawn them out. You guys can write them down. We are going to do them again. You do not have to worry about it. But we're first going to apply the definition of a derivative to find out what a value of a derivative at a point will be. The other word to use for the definition of a derivative is first principle. So in an exam, what you'll end up hearing is that, or reading, is that they ask you to determine the value of the derivative using the definition of a derivative. They very rarely use that in Sackeye papers. They mostly use by using first principles, calculate the value of a derivative at this point. So then you know that you need to use this item. If they do not dictate to you that you need to use the definition of a derivative or the words first principle comes up, then you will definitely use the rules for differentiation. I'm not going to scare you with these just yet. We're first going to deal with that. Okay.